Hello students, in today's class we'll learn about particle dynamics. In other words, we'll learn how particle works in a state of motion. Before that, why we are learning this chapter, we have to understand it. This is the reason behind it, because all the considerations are done in static mode, but whereas the practical scenario, everything is not done in static mode, because we are considering in a frame of reference where both frame of reference once is considered to be in static, and from there we consider or in other words we consider the instantaneous attributes like instantaneous force, instantaneous velocity, acceleration, xyz, everything. But the problem arises from here that it is not actually the thing. There is a dynamics. The dynamics works over there, like velocity or acceleration, which works with both the reference, both the frames, the working frame and the visualization frame. So let us start. So this includes two things. One is kinematics and one is kinetics. So kinematics is a study where we do with the displacement, velocity. The reference is where the motion is going and what are the main factors of the cause for the motion. So this is what kinematics says. So everything is same. It will be about with respect to time, but the thing is that we are not it is independent of the motion, reference of the motion, where it is causing, what is the reason of the motion or the forces. Motion means in the forces only itself. Kinetics, what are the kinetics? Study of resulting the motion or the forces. That means kinetic means what are the forces which make this body to be in motion, and what are the things cause. That means the cause is understood in kinetics, and kinematics is the how the motion is studied, but how the force is applied is not studied in kinematics. So the difference is one studies about the how it is happening, another studies about the source, how it's acting. So this is what happened. Kinematics works about how it is working and how everything is going with reference to time, but kinetics, in kinetics we don't see these things. We go for the resulting the forces, study of the forces, what comes, I mean what, from where the force came and why the force came. So the source we study in kinetics. Okay, next. So the motion has been divided into part. One is rectilinear and another one is curvilinear. So rectilinear is a motion where a body moves from one point to another point in a straight line, and curvilinear is, it will be a curve. So curve means that can be an arc, or that can be a rotation on like this along a rotation an axis, or it can be a circle. So it depends on what types of it, or it may be a curved thing like irregular curves. So anything can happen. So rectilinear motion, as you can see, this is the example of rectilinear motion. And rectilinear motion, if I consider this is our initial and this is our final point, and we could derive something that if it goes from right to left, left to right, it is termed as positive, and left to right is termed as negative, because we go for this. This is a consideration that doesn't mean that it's actually negative. We consider it to make it more easier to understand. So what happens is we could get we could plot this data. We can plot data from here, from there, by getting all the data, all the values. Or in other words, if we plot the distance traveled with respect to time, this will give me us an equation. So equation, if the equation is a linear pattern, so we could say that this is a rectilinear motion. If the equation is not in a linear pattern, then we could consider it as a curvilinear. So this is what we are doing. So for instantaneous velocity, just for instance, we can as we know that del t, that is the time, cannot be 0. So we shall limit del t tends to 0, or velocity. So what is velocity? Distance the change in distance by change in time. So the change in time cannot be 0, it's impossible. So that's why write del t tends to 0, and we could reduce it to dx by dt. That's what we do. So from there we could see, as you can see, dx by dt. So here from here again you can see this is a this is a linear graph over here, as well as the linearity. You can see the linearity that this graph this is going in the negative direction. So everything can be understood by this equations, what we equation of acting on the particle. So this goes for the acceleration too. With acceleration, we could see that acceleration decreases at a constant acceleration over here. So because we have considered this this criteria. So what happens, the velocity is increased, and then it is decreasing. So this for that reason, the acceleration also it is going towards the retardation. That's why it's a minus, as you can see, and the equation still remains now and then the same. So again, what do we know about acceleration? It is the ratio of velocity to velocity, changing velocity by time. Again, we know that time cannot be 0, so it tends to be 0, and therefore you can write dv by dt. Again, we know v is equals to dx by dt, so this is nothing but a double differentiation of d square x by dt square. So after that we could get acceleration equals to this thing. So that means if we differentiate with time, we'll get this one. Okay, fine. Rectilinear motion. So rectilinear motion will be given by this one, 6t square minus, as I have told you, this the same thing, the position. This was my position. From there I deduce velocity. Again, from there I deduce the acceleration. So these all things are working in one another. So it's for 0 0 0. So there is a you could see that how it behaves in a rectilinear motion. Okay, so this is what we have learned from here. For every time we could plot any data. So this is what we do in rectilinear motion. So what happens, this is a straight linear equation. Then for that we get a linear equation velocity, then acceleration due to linear acceleration, which is nothing but is my rectilinear motion. Okay. Determination of the motion of particle. So what we do, as I have told you, so what we do, v is equals to dx by dt, as well as you know, a is equals to dv by dx, a is equals to d square x by dt. So this thing can be broken into parts, dv by dx by dx by dt, or I could write dv by dt, I could write dx by dt as v, so dv by dx. So this can also be written. This is also a reduction form. So this is what we can do. We could determine this everything into successive integrations also. By integrating everything, we could also go back to the things. Okay. Determine the particle, the acceleration. If a alpha, from that we got that acceleration is a function of time. It depends on the time. If the time, as we know, that's why we could write a is equals to ft is equals to dv by dt. So dv is equals to ft into dt after integrating with lower limit 0 and maximum limit t. So we'll get a equation of this one. So again, for velocity, this stays the same, dx by dt. So this is all the mathematical derivations what we can do. And acceleration for in terms of acceleration, in terms of the distance or the displacement, what has been taken in consideration, then it will be of dx dx and x naught to x. This is the change in the distance, and then v is equals to dx by dt and these things. For acceleration to be the function of velocity, the same thing for the integration, we can do 0 to t and dt, and we'll getting this one, that is acceleration is equals to dv by we could deduce in this mathematical form, that is a is equal to fb is equals to dv by dt. So after that we will integrate to the limit of 0 to t, and we will get this equation. Again, for this one, for for this things we can go for velocity also. We will get this thing. The procedure establish what does it mean, that if you go for acceleration in terms of derivatives or in terms of integration form, you will get the same now and then the same answer. So what is the problem and what we have to summarize? For instantaneous velocity, we have to go for differentiation. For instant at 12 seconds, at 13 seconds, for that we have to go for differentiation. But if we need for the overall time limit from 10 to 20 seconds, that means that duration, we have to go for integration. That will give us a bigger clear picture. So integration and differentiation are both the things which will be required for understanding the particle dynamics. So this is the sample given as this is a question. As you can see, I would like you all to do these things. Again, there is a sample or there is a solution also, but you do and send me the how you have done. I have given it to understand, but the thing is you have to use the another method or try to do in another way around. So, and explain me by the steps why it is happening. So again, for this types of solutions, I will be giving you for downward falling. It was going upward, now it's for downward. So this is what happening. Now uniform rectilinear motion, that means if it's a constant, if my velocity is constant, that means it will be then we will be getting this x is equals to x naught plus b. How I can get dx by dt is equals to v is equals to constant. So I can integrate in x naught to x as a limit of length and limit of time, and I can get x is equals to x naught plus vt. Same for the uniform rectilinear motion. So I can do dv by dt is equals to a is equals to constant, and v naught by v dv is equals to a. 0 and t is the is the limit, and I can go for v minus v naught is equals to at. So this gives me some equations. What we know, v is equals to v naught plus at. That stays good for the x is equals to x naught plus at also. Similarly, I can go for the x is equals to x naught plus vt plus half at square, what we have studied. So x from there, if we short smaller up this, then I can write that x is equals to vt plus is equals to half at square. As well as I can write the v square minus u square plus 2as. What we can write this, if I consider this as an s, and if I consider x minus x not 0, then I can say s is equals to vt plus half at square, initial velocity and final velocity. Initial velocity considered to be a v and v naught to be the final velocity. It's in some books when we write u also. Okay, the motion in relative, what we have said. So relativity in the equation is that you have to understand from the from your basic knowledge, what you have studied in your college, in your school, that was in vector. Okay, so what happened, you know that, but I'll give you a revision that from a point, that is xa, b point is xb. So xb by b by a means the distance between a and b. So this is what we do, it's a relative motion. So similarly for that I can write v b by a. So this is what happened. So if you need to find a distance between this car and this car, that is red car and the white car, x red car x red car minus x white car is equals to x red slash white. So this is all the notation factors. This goes same for the acceleration also, as you can see, same for the distance, same for the velocity, and same for the acceleration. So don't mess them up. They are very easy. Okay, they are just taking the reference. Okay, the same problem. I'll be you have to do these things, falling of ball and how it falls. If a slab is kept, what will happen? So do you have to make the understand solution you have to give me. I'll be seeing the other way solution, not this one. This is only for your reference to understand. You have to give me other solutions also. Okay. Okay. So applications, as we know, the applications in everyone, like for the earth mover, for lifting, we use dozers, drawers, or the cranes. Everything we use over there in this same phenomenon, and this gives us a great result. So same thing, as you can see, this lifting. So this is also for same for this one. So this goes for the sample as the same question, you have to answer it. I will not do the problems, you have to understand. So this is what about rectilinear. Curvilinear, in curvilinear you have to understand this is the other way around. It's the same thing, but you have to consider in terms of circular motion or a motion of arc. That is called curvilinear motion. This will not be a straight line, it will be a a curve. So what will happen like this, as you can see, this aircraft is getting up with the curve. This is what is termed as curvilinear motion. So what will happen, we could just draw the tangent vector, and from the reference point we would see from which point to which point is moving, and this gives us as a resultant velocity, which helps to understand. So this is called a position vector. This is the position vector in which direction it is moving with velocity v. So this is what we are doing. It is moving at r distance. That's what del r by del t. So dr by dt v is equal to v. So it considers the omega. Again, v is equals to ds by dt, we know. So this is for linear velocity, linear or rectilinear, and this is for curvilinear velocity. Okay, or you may say in other words, it's a scalar and it's for the vector velocity. Okay, this is for scalar and this is for vector. Because you can see the vector will give me we are working from the reference, that's why we have to take the dr in consideration. But here we are considering the length, so this is give us the magnitude, that's why it's on the scalar and this is on the vector. So vector, the tangent as the path, as I told you, this is the path of the body where it wants to move, as well the same for goes for the acceleration. So this is if tangent on the path, and we can get all the results. So this is what happens. If I go for x, y, z vectorically, so there I will be getting x I cap, y z cap, z k cap. So this is what happening. Velocity vector is equals to dxi. So as we have known that x, if change in x, that will be velocity, dx by dt, dy by, that means we are differentiating. Fine. So velocity vector, after that we can put dot, means it's differentiated. So I got vx, vy, vz. The same math, simple. Similarly for the acceleration, we could get this one. Again, for rectilinear component of component, we could get component of acceleration. From that we could also get this one, that a is equals to x, double differentiation is equals to 0, y double differentiation is minus g, that is if it's a in terms of projectile motion. So you have to consider in the terms of projectile motion also, because it's very necessary. So what I can do is vy is equals to vy naught in minus gt. That is why, how I wrote this. So I know that vx is equals to vx into v naught. So as I know that vy is equals to v naught minus gt, and from where I can write, I know that the overall velocity, change in velocity, can be written in this manner. So again, for the distance, what I know velocity is equals to change in distance. Velocity is equals to change in distance by time. So after that deduction, I could write x is equals to v into t. Then after for similarly for y, I can write this one, and the change in the velocity. Okay, fine. Or in the equation, as I know that from these two, we can say v minus u is equals to gt or at. Or I can write s is equals to vt minus half gt square. Okay, the same thing we are doing. Motion in vertical direction in uniform accelerator. So as I have told you, there are things. Okay, second, next. So example I have given you, that remember, we need to remember this one, v is equals to v minus. So we are applying the rectilinear motion in the curvilinear just by changing some factors. Okay. So you have to understand, you have to give me the answers. I will not give you this one, because I will give you the second video how to solve, but you have to try, because you have to write in exam. I will help you out how to first make mistakes, then only I will be there. The mistake, it is allowed to take mistakes before exam, not in exams, not during exams. Okay, natural, what is in tangential and normal component. So as I know that 90 degree it's working to the point, then it will be a normal component, and tangential is the tangent to be there. So what I can write is according to the equilibrium, I could write that is, it is nothing but et. So et is the unit vector in tangential unit vector which is working, is equals to et plus, that means it's changing, et dash, it's changed from point to 1, point to 1. So I could write this equals to this plus is the change in this point. That's what it is given. This is equals to this, because this point have to recover this point to get some much more velocity to get over there. So we have to do is equals to plus del E. From geometry I could write dE by is equals to d theta. That means every change over here is giving you equals to d theta. So after that again I could write for d theta is equals to d theta, and that means it will also change from here to, it will change from here. So that from that I could get a d n is equals to dt by d theta. Okay. Tangential and normal component, as you know, alpha a is equals to dv by dt is equals to dv by dt into e t plus v dE by dv. As you can know that it's just a deduction as we have got over here. From here we can write that if this is a component et is working, so from there I could shortcut and we could deduce in this manner. But from that we could get that ds by dt is equals to v, that is ds is the small arc change by time is equal to velocity. So again I know that alpha a is equals to v square by rho. Okay. So this is what gives me a complete thing. So after substituting, that means what I have done, rho is because this things I have done, ds by dt is we have considered as rho. So why I have done it, we have considered the change in distance with change in this one with time is considered as rho. Okay. So we have considered it rho just for understanding purpose. So I could say a is equals to dv by dt e to the power t plus v square by rho from v square by rho o e n, that is the normalization. Normal, that is over here. From there I could draw this. So after that substituting we could get that alpha t acceleration at t is equal to dv by dt, acceleration at normal is equals to v square by rho. So radial and component, as I have discussed, this r is equals to r by e, and particle we know v is equals to the same derivations, what is the dv ratio. Then after that there is a change in small changes have been considered, and we got this equations. So v is equals to r e by things. The same things we have done only mathematical things. So alpha acceleration rectilinear curvilinear motion will give me this things. Okay, fine. Sample problem, as you can see, you have to do and you have to give me the answers. Okay. After that I have given all the things for you. Just you have to go and you have to solve this problem. Okay, fine. So this is for another question, as I have given a sample problems for your exam. So after among them you will get in your exam, because these all are important. So thank you.